In the previous lessons, we were able to prove or to show that if a line joins two midpoints of two sides of a triangle, then it will be parallel to the third side of the triangle, and it will be equal to half of the third side. We have done it through investigation. We also did it through deductive proof. So let me do the illustration as we did before, so that you should be able to remember what we did. What we had is a triangle, like this. Let's say it's triangle ABC, and this is a midpoint, meaning that this side is equal to this. Say this is D, and we also have another midpoint here. We can call it A, and that tells us that AE equals to EC. This side is AD equals, these two are midpoints. So we were able to show that once we join the line segment, the two midpoints with a line segment, the line segment will be equal to half of BC. The DE will be half of the third side, or we can say BC will be equal to double DE. And again, we're able to say if that happens, if this line segment joins two midpoints of two sides, DE will be parallel to BC. That would happen in any case. So we want to do a diagram analysis on this problem. We've got triangle ABC, P and S are midpoint of AB and AC, meaning P is halfway, AP and PB are equal, AS and SC are equal. That is what we're able to establish. If we were to use this sketch, it shows that PS will be parallel to BC. Once a line segment joins two midpoints of two sides of a triangle, then that line segment will be parallel to this. And what we know is that PS is half of BC again, which simply means BC is twice PS. Okay? And let's go on. We concentrate on this triangle. We've got a midpoint there. Therefore, QT is equals to QB. TR is equals to RC. Therefore, if we join these midpoints, this is what we're going to have. QR will be parallel to BC. And one other thing is that BC will be twice. Remember, QR will be half of BC because of this midpoint that have been joined. BC is equals to twice QR. Okay? This is what we have. At least this gives us an idea that PS is parallel to this, and QR is also parallel, and meaning that QR and PS are also parallel. And they also question, both of them are half of BC. Okay? So now let's come to the proof. Let's come to the proof. Prove that PQRS is a parallelogram. PQRS is a parallelogram. PQRS is a parallelogram. That's what we want to prove. So already we know that PS is parallel to BC. Midpoint theorem. PS parallel to BC. This is a midpoint, and midpoints being joined, therefore if midpoints are joined, therefore that line segment that is joining midpoint automatically is parallel to. And one other thing is that we know that this BC, because of these midpoints, BC is equals to twice PS. Again, because of the same thing, midpoint theorem. Okay? And what else? We'll come to this smaller triangle. QR is parallel to BC. Midpoint theorem. QR, because of these midpoints that are joined together, that leads to parallel midpoint theorem. QR again. But one thing that we know that QR, because it's now parallel to this, it's also half of BC, or BC is twice QR. Midpoint theorem. Now, based on these two statements, okay, PS parallel to BC, QR parallel to, therefore, PS and QR are parallel. Both parallel to BC. Okay? Both are parallel to BC. And we have these two statements. PS and QR are now equal. Both are equals to half of. Both are equals to half of BC. Remember, because of these two statements, they are all equals to half of BC. So using these two statements, PS parallel to QR and PS equals to QR. Therefore, PQRS is a palm. Quad whose side is parallel whose opposite sides are parallel and equal, then it is a palm. It's a parallelogram. So this is what we were able to establish. There's two parallel. Once these are parallel, we're able to establish these are parallel, and we're able to establish that they are equal. Once these pair are equal and parallel, then the PQRS is a parallelogram. So that's what we're able to establish. Now I want to do an exercise. Now you can see these are diagonals bisecting each other, meaning that it's a midpoint. And we were already told that SC and CT are equal. So C is a midpoint. So we've got the midpoint of this triangle, SQT, and the PQR. This is also a midpoint. So you can be able to, through congruency, you can be able to establish that QR and SR is equal. If you are able to establish that this is equal to that and parallel, you can establish a parallelogram. And if AC, you can relate it to PQ using the midpoint theorem. Relate it to QT. You can as well relate it to PT. Now that will be done. I hope you have enjoyed this lesson. Thank you very much. Subscribe to the channel.